We are going to be looking at section 2.3. This is polynomial functions of higher degree. Ultimately, what we're going to be looking at is some things we've already talked about in class, but we're going to kind of focus in on, well, what happens if I don't have x squared? What happens if I have something bigger like x cubed or x to the fourth or x to the fifth? For the next several sections, we're going to be discussing exactly how to solve these, how to find zeros, how to describe the end behavior, how to analyze the function in general. The first thing we look at here is just polynomials. Let's go back and just kind of define, let's define our definition of a polynomial. And we talked about it earlier as polynomials having whole number exponents. It has no discontinuity. It is a smooth curve, things like x squared, x cubed, x to the fourth. All these things are what we would consider to be a polynomial. And you can see here, you've got a smooth curve. So this is by definition of kind of what you think of a polynomial as. This is some type of cubic equation. Over here we've got a piecewise function. It looks like a maybe a cubic or even two parts of parabolas. It's definitely not a polynomial because it's broken. Here we have another. I don't know exactly what this is, but it's going to be 1, 2, 3, 4. This is a fifth polynomial because I can count the times it changes directions. I know it's all odd because one is going down and one is going up. This is a polynomial. It's smooth curve, has no breaks, no points, things like that. And so we can look over here. What you see in this section is it's continuous, but it's got a really sharp point right here at that one value. So it's almost like another piecewise function. It's not just to be continuous, but it's got to be a smooth curve, just like this one. And so if you have that point, that also can't be a polynomial. So the graphs that we're going to be looking at are going to have these types of smoothness to them, not like what you see on the right hand side of the screen. These are definitely not polynomials. Let's talk about the end behavior of polynomials. Now, we've already talked about this a number of times, but I just kind of wanted to reassert this and just kind of recover it a little bit. We call it the leading coefficient test because what we look at is we need to find the degree and the sign of the leading coefficient. And so there you can see here it's the sign and the degree. So if it's odd, that tells me something. If the exponent is odd or even, that's going to say one thing. If this positive or negative value of the coefficient is going to tell me something. So let's look at the end behavior in general. So I'm going to put up here as a chart. If you need to pause the video and copy these pieces down, super valuable. If you already kind of got end behavior down, then you already know this. But maybe this is something that just hasn't quite sunk into your brain yet. So pause it if you need to copy this down. So here we're going to look at what happens if my leading coefficient term is positive and the exponent is even. Then it's going to look just like this. What that means is you're looking at the end behavior for every single polynomial that has a positive coefficient. That's an right here, and the nth degree is right there. That's telling you that it's going to have, as x goes to as p of x, that's f, as f of x goes to positive infinity, x goes to negative infinity, right? And so as this is f of x goes to positive infinity as x goes to positive, so this is as it's going to the right side, and as it's going to the left, f of x pretty much goes to positive infinity in both cases. Pretty obvious. If you look over here, what happens when my leading coefficient is negative and it's still even? Well, it just flips upside down. Instead of going to positive infinity, you notice that your p of x's are going down to negative infinity now. Pretty obvious, though, because it's going down. Well, what if it's positive? These are your two values. Sorry about the blurry part. If it's negative odd, and then it's going to look like negative x cubed. And it's just going to be opposite signs here. So you've got as x goes to negative infinity, your y value is going to go to positive. As x goes to positive infinity, f of x, or in this case p of x, goes to negative infinity, goes down. So you've got positive even, positive odd, and negative odd. This is it. When we're talking about end behavior of polynomials, there are no other options. The 4 choices here are what's going to end up being there. Now, we've talked about in behavior with rational functions, with the fractions. They're not polynomials. Square roots, not polynomials. Okay, so those types of equations are different. We're talking about just, in this case, in behavior of polynomial functions. You're looking at your only options here. Know these. Pretty easy once you figure out just if you look at the number of the degree, which is odd or even, and you look at the leading coefficient, I just need to know if it's positive or negative. Learn these, and so when you get to an in behavior question, it's pretty simple. Okay, just one real quick. One time, it's up on both sides. That's a key factor. This one's going to be down on both sides. Here we're going to go up to the right, but down to the left. Okay, down to the right and up to the left. So however you kind of remember that, remember how those kind of play a part. Those are the key facts. Make sure you know those. Okay, let's just practice this for a second. Determine the behavior of the following. F of x equals negative x cubed plus 4x. And so if we think about this one, easy enough, it's negative odd. The exponent is odd, the degree is odd, the leading coefficient is a negative 1, and so it's going to look like negative x cubed. I don't really care what else is attached to that part of it. Just the leading term is what I'm looking at. And so in this case, if it's negative x cubed, then it's going to be going down to the right and up to the left. So if we talk about in behavior, as x goes to positive infinity on the right side, f of x is going to go to negative infinity. As x goes to the left, or as x goes to negative infinity, y is going, or f of x is going to be going to positive infinity. If you need to pause, look back at your notes, double check negative odd, and that's your answer for this one. Okay, here we have a positive number out front and a 4 for my exponent. That's going to tell me, so it's positive even. This one's going to look just like x squared. So basically your f of x's are both going to positive infinity. This one is positive odd. This one's going to look like x cubed. So it's going to go, as x goes to the right side, as x goes to positive infinity, my f of x goes to positive infinity as well. As x goes to the negative side, as x goes to negative infinity, then y, or f of x, is going to go down to negative infinity. Double check your x cubed or your positive odd note apart from the last slide. Okay, now you can confirm these things. We'll do the first one just to look at it. We'll look at y1, which is negative x cubed plus 4x, and we'll just graph that real quick. Let me make sure I'm in the right zoom. So I'm going to go zoom 6 because that's going to be my standard view, and I'll just look at my graph. And there we have that's pretty much looks similar to negative x cubed. And we said as x goes to the positive side, then y, f of x, would go to negative infinity, which is confirmed there. As I go to the negative side, as x goes to negative infinity, y, or f of x, goes to positive infinity. No big deal. Let's look at the second one. So I'll turn this one off by hitting enter on the equal sign, and turn this one on same way. We'll hit graph again. This one should be like x squared, and here it is. It does have a little hump in the middle, but that's no big deal. I am not interested in what happens in the middle. This is not in middle behavior. This is end behavior. And so you see that they both go to positive infinity. And so you can see very clearly that as long as I know the positive and odd, or negative even, those 4 situations, in behavior becomes very simple. Let's go back and talk about zeros of a polynomial. A little bit of definition or a vocabulary here. If I know the degree of f of x, then I know that f of x has that many, at most, that many real zeros. Now, we're distinguishing between real and imaginary. Okay, some of our solutions in this chapter are going to be imaginary zeros and real zeros. We're focused on the real zeros right now. So if I were to graph certain functions and look at them on a graph, those zeros would be exactly where they go through the x-axis. But you'll discover in this lesson today that I'm going to have some equations that have an exponent or a degree of 5, but they're only going to have 3 zeros. So that means the other 2 that I didn't find are imaginary. Okay. The function has at most n minus 1 relative extrema, mins or maxes. So that means that for x squared, you know that it's only got 1. It's got a vertex, and that's either going to be a max or min. And so if I take that, think about it, well, x squared is a degree of 2. So 2 minus 1, if I plug that degree in right there, 2 minus 1 is 1. So tell me, well, you're going to have at most 1 maximum or minimum. And then you can do that for x cubed. You would have at most 2. Now, be careful, because x cubed by itself doesn't have any max or mins. Remember, this is at most. But when I start to play around with x cubed like we had earlier, when we had this one, this is x to the 4th, right? So 1, 2, and 3 times. But if I just want to graph x to the 4th by itself, I have 1 minimum, or if it's negative x to the 4th, it's 1 maximum, right? So be careful. It's at most. It's not exactly. Okay, one last thing, and when we find zeros, well, and we're going to do this in just a minute, the test of a zero is basically set the polynomial equal to 0 and solve for x. Now, with quadratics, we have a number of ways that we can solve that quadratic formula, completing the square, square roots, factoring. All those are valid methods, and you're going to have to be able to decide what's the best choice for you. We are going to study some in this chapter where it's really going to be a different method, where I'm not allowed, I don't have a quadratic, so what do I do after that? All right, so here's a little bit of vocabulary. X equals a, that's my 0. X equals a is also called a solution of the polynomial when it's equal, when f of x is equal to 0. Right? So I'm just trying to define a couple of words that we use. X minus a, that's different from x equals a. Similar, in this we get the x equals a from the x minus a, but this part where it's still written as kind of a term, it's called a factor. So when you factor the polynomial, if you had something like x squared minus 4x plus 4, then it would factor into x minus 2 times x minus 2. Well, those x minus 2's are factors because I've factored the polynomial, pulled it apart. Okay, until I write it as this, I don't have zeros, or roots is another way of saying this. Roots can be synonymous with 0, and we'll be using those interchangeably lately. A comma 0 is always an x-intercept, and the key connection here, x-intercepts and zeros are exactly the same thing, except I write an x-intercept as a coordinate. I write a 0 as this. Make note of that. When I ask you for zeros, you can write it down like this. X equals 5, x equals negative 3, x equals square root of 2. But if I ask for the x-intercepts, well then I'm actually wanting you to write a coordinate that would be like 5 comma 0 if it was that, or square root of 2 comma 0. It doesn't matter. Know the differences between intercepts, factors, and zeros or roots. 0 and roots can be used interchangeably. They're about the same. All right. We're going to find the zeros of a couple of polynomials. And so it says find all real zeros of the following. And so what I want to do is I want to look at this one and I want to find the zeros. Now, what would be the method of choice here? Personally, I would factor out my x. If I factor out the x, then I'm going to have something that I'm more familiar with. I'm more familiar with a quadratic, and then I can solve that. What I want you to do is pause the video. I want you to try and factor this one on your own before I just tell you what the solution would be. Okay, you really should have paused it if you didn't. You're not going to learn anything if you just listen too much anyway. So what you should have done, you should have gotten 0, or you factored your x out, and this is what you should have. X minus 2, I'm sorry, back up. should be x parentheses x minus 2, close your parentheses, open a new one, and then x plus 1. So what that means is my factors are x, x minus 2, and x plus 1. My zeros, checking your vocabulary here, are x equals 0, x equals 2, and x equals negative 1. And I got those by setting each of the factors equal to 0 and solving for x. Now we want to write the x-intercepts, then these are your x-intercepts. 0, 0, 2, 0, and negative 1, 0. Each one of these, and if you were to graph this, then what we would see would be each of those as they crossed over the x-axis. And we'll look at that here. Or maybe not. Yeah, there it is down there. If I were to graph this, so you can see it negative 1, 0, and 2. Double check that. We can look at our table of values. So we have negative 1, we have 0, and 2, just like we saw earlier. Now, and I've mentioned this a number of times, there's going to be times where I'm going to ask you to use the calculator to help you to do things, and there's going to be times where I'm going to say calculator's off limits, and this is going to be one of those times where I really don't want you to use the calculator too often. Okay, here's another example. I want you to find the real zeros and the extrema of each of these. Okay, use your calculator to help you find those extrema values. Pause the video and do it now. If we go back, we're going to look at this one on the graph. Now, to factor this next one, I would have factored out my negative 2x squared, and that would have left me with x squared minus 1 as a solution. And so you would have had factors of, you can write this down, negative 2x squared, x minus 1, x plus 1, because x squared minus 1 is a difference of squares. So you would have had zeros at x equals 0, x equals 1, and x equals negative 1. Let's go ahead and find those max and mins using our calculator. So we'll graph this one. So we're going to hit zoom 6. I think I already had it there. So I can see here, it's like, oh, that looks like a max right there, but let's go ahead and zoom in on that real closely. I'll use my Z box to do that. I go over to the, I'd always go to the left. You could go to the right or whichever way. But I want to kind of zoom in on that one point, that one little section where it looks like it's kind of, it's a fourth power, so I would expect it to look like a W or an M. In this case, an M because it's upside down. But I can't quite see the peaks on those. There we go. Perfect. So we're going to use our max and min features here. So I'm going to press second, trace, and I'm going to use my minimum. We'll do 3, and I kind of have an idea what my minimum is, but let's just confirm that. I think it's 0, 0, and it is because that's one of my zeros. We'll just hit enter again, and just for the sake of it, we'll get close, and we'll find that. Now be careful. It says negative 6.1 times 10 to the negative 7th, and whatever. That's nothing more than 0, 0. Okay, let's try another one. We'll do our maximum here, and I'll do 4. I'll find the right side, and these graphs are symmetric, so you're going to know that whatever I find here, that maximum is going to be almost the same on the other side. It's just going to have a negative x, but the same y. And there we go. So my maximum here is 0.7071. We'll round it to 4, comma, 0.5. And I can tell you right now that the other side of this one's going to be the exact same, except the x is negative. Right? And you could find that out if you want to using your maximum. Just go to the other side. Okay, if you need to rewatch that part, rewind it, watch it again, and make sure that you know how to find those things like that. Here's a big one. Lot of equation, a lot of pieces, big exponent. How many zeros should I be able to find here? Well, from the degree, it says that it's I should be able to find at most 5 real zeros. Okay, let's go back and let's see what we can find. We're going to look at the calculator version. This one we don't know how to solve yet, and so I don't expect you to do this one by hand. I do expect you to be able to use your calculator on this. Now we will investigate in a couple sections later exactly how to look at this one. So this one's kind of odd. I'm going to zoom back out because I had zoomed in earlier. So we'll go back to zoom 6 and look at this equation. And there we go. We have 1, 2, and 3 zeros. What that means is, and this I mentioned this earlier, there are 2 zeros that are imaginary. So I'm going to have 2 values that I'm not going to be able to find at this point. So what I'm going to do is I am going to use my 0 feature because I got a feeling these aren't going to work out to be whole numbers. And that's okay. So second trace, and 0 is your second option. So hit 2. I'm going to scroll back and just find this one here. Hit enter. I'll scroll forward just a little bit and scroll back. Kind of get as close as I can, and then I'm going to hit enter. And it's going to show me my 0 is at negative 0.2541. If you didn't really look at it closely enough, if you just kind of guessed, you might have thought that was at 0, 0. Be careful. Don't assume anything. And I would find the other 2 graphs just the same way. Let me scroll back. Second trace, we'll do 2. This time I want to scroll back this way. I got to get past it. I think I did pass it. Okay, good. I'll hit enter and I'll pass it real slowly here because I know my graph is going pretty steep at this point, so it's going to move pretty fast. So I'm going to go back, get as close. It doesn't matter. As long as you're within your 2 points earlier, you'll find it. And this one's at negative 1.86. And you'll find your other one, and just to save time, the other one is going to be 2.115. And that's it. Here's your homework. Make sure you write this down, pause the video if you need to, and go back over this. If you need to rewatch a couple of parts of it, go ahead and do that too. Just make sure that you know how to do each of these pieces that we talked about today.